Hello everyone, my name is Prabsimar Kaur and in this video I'll be demonstrating my task 8.1 HD. The objective of this task is to establish Bluetooth communication between two embedded systems, the Arduino Nano 33 IoT and the Raspberry Pi to build a reverse parking assistance system. In this setup, the Arduino Nano acts as the sensing subsystem which detects the distance using an ultrasonic sensor and light intensity using an LDR sensor. The Raspberry Pi acts as the actuating subsystem which receives this data over Bluetooth and uses it to control an LED that indicates that how close the car is to the wall. This project simulates a real-world reverse parking scenario. The wall-mounted Arduino continuously measures distance from the car using the ultrasonic sensor. At the same time, the digital LDR acts as an emergency detector. If the car gets extremely close and blocks the light, it triggers an emergency alert. This data is sent wirelessly via Bluetooth Low Energy to the Raspberry Pi, which interprets the distance and adjusts the light LED brightness accordingly. Dim when far, bright when near, and full intensity in emergency. Now let's look at the hardware components used in this project. We are using Arduino Nano 33 IoT, which has an inbuilt Bluetooth Low Energy used as the main sensor node, an ultrasonic sensor connected to the digital pin D3 for the trigger and D4 for the echo for distance measurement, an LDR module connected to the digital pin D2 to detect light levels and act as a proximity emergency sensor. Raspberry Pi serves as the central microcontroller and actuator, receiving Bluetooth data and controlling the LED. An LED connected to the GPIO pin of the Raspberry Pi to visually indicate the distance. Both the Arduino and Raspberry Pi share a common ground when powered from their respective USB cables. On the software side, there are two main programs, one on the Arduino and one on the Raspberry Pi. The Arduino code uses the BLE library to advertise a BLE service that continuously transmits the data. The ultrasonic sensor measures the distance in centimeters and LDR provides a digital high or low signal. If the LDR detects darkness, meaning the car is extremely close, the Arduino immediately sends a zero value as an emergency alert. Otherwise, the ultrasonic distance is mapped to a range of 1 to 255 and sent to the Raspberry Pi through BLE characteristic. On the Raspberry Pi, Python script written using the Bleak and RPI GPIO libraries connects to the Arduino, receives the data in real time, and converts it into LED brightness using PWM, that is pulse width modulation. The LED glows brighter as the car gets closer, giving a virtual signal to driver. Let's see how the Bluetooth communication works. The Bluetooth communication is established using the BLE protocol. The Arduino Nano acts as a BLE peripheral. It advertises a service with unique UUID and a single characteristic that holds the distance value. The Raspberry Pi acts as a BLE central. It scans for Arduino device, connects to it, and continuously reads the transmitted data. BLE is chosen because it's a low power consumption, high reliability, and easy device pairing without the need for complex wiring. Now let's see the system in action. As I move my hand closer to the ultrasonic sensor, the Arduino measures the decreasing distance and sends the value to the Raspberry Pi. On the Raspberry Pi, the LED brightness increases, simulating the car approaching the wall. When my hand gets extremely close and blocks the LDR, the LED immediately switches to full brightness, indicating an emergency or collision warning. When I move my hand away, the light dims gradually, showing that the car is now at a safe distance. This demonstrates the combined functionality of distance sensing, light based emergency detection, and wireless data transfer through Bluetooth. This task demonstrates several key embedded system principles such as sensor integration, like we are using multiple sensors like the LDR and the ultrasonic sensor, signal mapping and conditioning, that is converting real world readings into scaled digital values. We are using wireless communication using BLE, establishing a reliable low energy data link between two embedded devices, actuator control, and safety responsiveness. In conclusion, the reverse parking system effectively demonstrate how the different hardware and software components can be integrated using the Bluetooth energy communication. It provides real-time distance monitoring, visual alerts, and safety features, all controlled through seamless interaction between Arduino Nano 33 IoT and Raspberry Pi. This project highlights the core of the embedded systems, sensing, processing, and actuating, working together to create a small and reliable application. Thank you.